Hello student, my name is Pathan Ahmed Khan and I am going to teach you design and analysis of algorithm subject in Department of Computer Science and Engineering, and your subject code is PC603 CS, and this is in your 6th semester, and this is a common subject for CSE as well as IT, but the syllabus is changed. So this is for the CSE. So first of all, we will see objective, what we are going to learn in this video. The first thing is, why do you need to learn this subject? This is very important. Why do you want to learn this subject? Okay, and the second one is, we will see the course outcome. That means is after finishing your this syllabus, what can you do, that we can see in the course outcome. And after that, we will see the syllabus is designed by the Osmania University, and that we will see the 5 units, and we'll see small introduction, what are the things are there in the unit wise. And the last one is book references, from where you can get the book for learn, or if you want to get the book in the library also, you can get it. So these are the things we are going to see in today's lecture. The first one is, why do you need to learn this subject? Whenever you are learning any subject, you must know why are you learning. First thing, that is in your OU syllabus to clear the exam, that is by default. Okay, the next thing is, in this the subject name is design and analysis of algorithms, that is in the short we can say DAA. So, and this design and analysis of algorithm, the name itself you can understand that whatever we are going to do in this subject, that will all come under in designing part. What is this designing part? Means before implementing anything, we need to make a design first. So before implementation, we need a rough copy of your implementation. Example, if you want to write a addition program in the C programming, if you want to write the addition program, so first if you write the algorithm, then it will be helpful for you. Okay, and what is the advantage of the DAA? It will reduce the cost, means it is economic, it is less expensive. We no need of anything to buy to write the algorithm. But for the implementation, if you go to the implementation, that is very important, because we need to implement the thing what you have in your idea. So for that we need a space, we need a power consumption, we need a software, we need a hardware, so a lot of things are there. So that is a little bit expensive, but if you come to the algorithm, it is less expensive compared to the implementation. Okay, you will get a clear idea before implementation, whatever you want to do in the implementation. So before, you will get a clear idea. What does that mean? Means if you take the example like civil engineering, if you take the example of construction the building, because everyone knows about this. If you want to construct the building, first you make a design on a paper. Okay, so the design on a paper, then we will implement on the real place. So that is in the same way, in the same way, we need to write the algorithm in the paper or in any language. This is, and it does not have any syntax, and it is a language independent. You can write in your own words whatever you want to write to implement. So if you have an idea, then you can implement in the any software. So before implementing, we need to write the algorithm in a piece of paper or anywhere in your own language. Maybe it will be English, Hindi, Urdu, any kind of language, whatever it is comfortable for you. Then after that you can implement in any other languages like Java, C, C++, in so on. Okay, so this is about the algorithm, and why the main important thing for this algorithm is we need to find the time complexity and the space complexity. What is this time complexity and the space complexity means? Time complexity means how much time is consuming for executing the program. If you are writing the program addition, in the addition how much time is taking. Okay, and in the space complexity, how much time is taking and how much space is taking. These two things are very important, and you will get before implementation, we will get with the help of design and analysis of algorithm. So this is the reason we need to learn this subject. Okay, design and analysis of algorithm, and this is come under in the designing part. Before implementing, we need a rough copy of your implementation. Whatever you want to implement, that we need to have a rough copy. It will reduce the cost, it will get a clear idea before implementation. It does not have any syntax, you can write in your own language, and the main idea for this is time complexity and the space complexity. Okay, so the now next objective is course outcome. What is course outcome? After finishing the course, this all 5 unit, what the student can able to do. First one, ability to analyze the performance of algorithm. Means whenever we are writing the algorithm, then you will get an ability to analyze the performance of algorithm. How the performance of the algorithm, how much time is taking, how much space is taking, then you will get an clear idea about that. Next, ability to choose appropriate algorithm design technique for solving problem, because when we have a lot of problems we can face in a programming, so for that kind of problem, which kind of algorithm we should select to solve that problem, then you will get an ability to select the algorithm, perfect algorithm for a given problem. Okay, so and what are the different techniques are there to solve the problem? So whatever the technique is suitable for that problem, you can select that. Next, ability to understand how to choice of data structure and the algorithm design methods impact the performance of program. Means when we have a problem like data structure, in this how the data structure we need to select and how the algorithm design method should be impact the performance of program. So you are going to see in your syllabus the different method, different techniques, different methods are there. With same problem you can solve with a different method, and which method is suitable for your given problem, you can select that and you can understand. And the last one is understand and apply different algorithm design techniques to solve real world problems and analyze their complexity. So actually for the algorithm, you can write the algorithm for anything. not only for the program like addition, subtraction, anything. Like if we have a traffic signal, okay, for that also you can write an algorithm. If you are preparing a tea, for that also you can write an algorithm. You can write algorithm for all the things. There has some characteristics in the algorithm. In the coming classes we are going to see that characteristics of algorithm, with the help of, if the problem has that kind of characteristics, then that problem we can write in algorithm. Okay, so that we will going to see in the coming classes. So this is about the course outcome. After finishing the course outcome, you will be analyze you will ability to analyze the performance of algorithm, and you can select the appropriate technique to solving the problem as per the data structure, which method we need to use to solve the problem, that also you can select. And for solving the problem, as well as we need to focus on the performance also, that is also you can complete here. And as per the real world problem, we can select the different algorithm as per the problem. So this kind of things you are going to learn, understand after finishing your course. Now we will move to the syllabus. In the syllabus, one thing I will going to tell you, uh, you CSE and IT both have the DAA subject, design and analysis of algorithm. But in CSE we have a little bit more topic we have compared to information technology. Okay, both syllabus are different, almost we will get the similar topic, but in the CSE we will have the more topic. Okay, fine. So in the first unit we have an introduction. So in the introduction we are going to see the algorithm definition and what is a specification, and we will see the asymptotic notations or asymptotic analysis, best, average and worst case behavior. And we will see the performance measure of algorithm. How will you performance measure of algorithm, how will you measure the algorithm. And we will see the time and space complexity, and we will see the analysis of recursive algorithms. So in the introduction part, that is very easy. We will going to see the definition, we will going to the specification like characteristics, then we will see the asymptotic notation, best, average and worst. Then we will see the performance measurement of algorithm, how you are going to measure the algorithm performance algorithm. This is the best, this is the worst, and this is the average, how we are telling that we are going to see. And we are going to see the time and space complexity, analysis of algorithm, analysis of recursive algorithm. Means recursive means it call by itself, how the algorithm will call by itself whenever it is required. Okay, and we will see the basic data structure. Already you completed the data structure in your second year. So here the basic data structure like disjoint set operation. What is disjoint set operation? And we are going to see the union and the find algorithm. These two algorithm is there. Definitely one question will come from union and find algorithm. And dictionaries, graphs, tree. We will going to see the basic data structure topics, because already you have completed this in the second unit. So here just mention basic data structures. Next one is unit 2, divide and conquer method. In this, like if we have a big problem, okay, if we have a big problem, that problem you can divide in a small piece of code or a small piece of small part, will solve that problem, and again it will merge together. So first it will divide all the problem and solve individually, and again after solving that, again it will merge and we will get the final answer. So with that, we have, as per your syllabus, merge sort and the quick sort is there, and worst, best and average case in the binary search. Already you have completed this. If you know the data structure, then it will be easy, this subject will be easy for you to understand. Okay, so what is present in the divide and conquer is, it will be a general method, and we are going to see the control abstraction, and we are going to see the sorting technique. Sorting techniques are more, but we are going to see, as per your syllabus, is merge sort and the quick sort, and we will see the different cases: best case, average case, worst case, and we are going to see the binary search. We have the next topic, that is brute force. Okay, and here we are going to see the computing and string machine, closed pair and convex hull problem, exhibit search, traveling sales per problem, knapsack problem, and we will see the assignment problem. This is nothing but like brute force attack, like it will apply the things again and again and to solve the problem. So that is, a traveling salesperson is there, knapsack problem is there. We will going to see that kind of problem, how to solve that problem in the with a brute force method. And in the second unit, the next chapter is greedy method. Okay, in the second unit we have a 3 chapters. First one, divide and conquer, second one is brute force, third one is a greedy method. In the greedy method, in the name itself you can understand, like greedy is nothing but like we can say like if we say in Hindi like lalach. In the same way, greedy method is also there. Greedy means every time it need a best and best result, every time it need a best of best. So there is a problem, knapsack problem, and we are going to see the job sequencing with deadline. We are giving the job and we are giving, as per with that we are giving the deadline also, and we are going to see the minimum cost spanning tree, and we are going to see the single source shortest path problem. So these are the things are there in the unit 2, and this is very very important unit: divide and conquer, brute force and greedy method. This is present in the second unit. Now we will move to the third unit. In the third unit we are going to see the dynamic programming. Okay, if we consider, if we compare the greedy method and the dynamic programming, greedy method is already predefined problem rules are there. Predefined rules are there. Every time the problem will go with the same procedures. And here in the dynamic programming, it will take a decision in every stage. It will take a decision in every stage or every step. When it finish one step, then again it will take a decision. When it will go to the next step, again it will take a decision. But in the greedy method, from one first to last, it will already decided route, it will already predefine selected the route, and as per that it will go. But in the dynamic programming, it will take a decision on every step. Okay, so there is, we are going to see the application of the dynamic programming, then we are going to see all pair shortest path problem, and we are going to see optimal binary search tree and 0 by 1 knapsack problem. Here I'm gonna tell you, knapsack problem is different and 0 by 1 knapsack problem is different. Okay, that you will going to understand when we complete that. So reliability design, and we are going to see the traveling sales person problem. So this is come under in the dynamic programming. In the dynamic programming, we have what kind of problem we can solve in the dynamic programming: all pair shortest path problem, OBST means optimal binary search tree, and 0 by 1 knapsack problem, reliability design, and the last one is traveling sales problem, traveling sales person problem. So this is about the dynamic programming. And here the next topic in the chapter unit 3, we have a 3 chapter. In the second chapter is a backtracking. Backtracking is, we are going to see the general method, recursive backtracking algorithm, and we are going to see the iterative backtracking method. There is a difference between iterative and the recursive. Recursive, it will call by itself a number of time as per the requirement. Iterative is nothing but like we need to give in the loop, and as per the condition false, it will come out from the loop. And the main important thing in this backtracking is, most famous is 8 queen problem, that is chessboard 8 queen problem. And we are going to see the Hamilton cycle, and we are going to see the next is 0 by 1 knapsack problem. And the difference between 0 by 1 knapsack problem and normal knapsack problem is, in the 0 by 1 knapsack problem will not allow the fraction value, means decimal point value will not allow in 0 by 1 knapsack problem. If you go to the knapsack problem, in the knapsack problem it will allow the decimal point value. This is a major difference between these two. Okay, third unit, third chapter is branch and bound technique. Control abstraction for least cost search, and we are going to see the bounding, and we are going to see the FIFO, first in first out, branch and bound, LC branch and bound, and 0 by 1 knapsack problem, LC branch and bound, and FIFO. LC is nothing but least cost, FIFO branch and bound solution, traveling sales problem person problem. Okay, you can see the same thing like here knapsack 0 by 1 knapsack, here 0 by 1 knapsack, here traveling salesperson problem, here traveling salesperson problem, but the method is different. The problem is same, but the method is different. After applying this, which one is the best, you can select. So this is the problem will be the same, but the method to solving that problem is different. And this is purely you need to do the practice. Whenever we see, whenever I upload the video, you must maintain the notes, otherwise you will be faced very difficulty, because this is difficult subject. But But if you do the practice and if you understand this, if you understand this subject, then it will be very very easy for you, because it does not have the theory, more theory. It is has more problems. If you are perfect to solve the problems, then you will be get very good marks. Okay, unit 4. In the unit 4, graph traversal, already you completed in the data structure graph, about the graph. So graph is graph traversal, DFS, DFS, BFS, okay, breadth first search, depth first search, and transitive closure, and we will see the directed acyclic graph, and we will see the topological ordering, network flow algorithm, uh, and the next one is tires, standard tires, compressed tires, and suffix tires, and search engine indexing, and external search, and B tree. This B tree, definitely one question will come with this B tree, so you must understand the concept of B tree. In the fourth unit, B tree is very very important, and graph algorithm is also important. Okay, the next one is in the last unit, that is fifth unit, computational complexity, non-deterministic algorithm, the classes p, np, np complete, np hard, satisfiability problem, proofs for np complete problem, clicks, vertex, cover. So this fifth unit, computational complexity, on this p, np, np complete, on this all this, still the research is going on. Okay, still the research is going on. So this is a very vast topic, and this is very easy if you understand. We are going to see this kind of problem in the fifth unit, p, np, np hard. Okay, and the last topic, last chapter of the last unit is parallel algorithms. Introduction, models for parallel computing, how the parallel computing is there, computing with complete binary tree. As you know what is binary tree, it is divided into two halves, less than and greater than, and the element should be in order. We are going to see about this also, binary tree. Okay, so in your syllabus we have a 5 units. Okay, and you can uh, make a note whenever I am teaching you, and take out the xerox of the syllabus and keep it in your book every time for reference. That will be helpful for you. Okay, so this is about the syllabus. Now the last one is book references. In the book references you will get this all books in our college library, ISL engineering college library. You will get it, this computer algorithm, fundamentals of computer algorithm by Sani, and data structure and algorithm is person edition is 2006, and that is Hopkirk and Jeffrey, and algorithm design by the John Valley in 2002, and introduction to algorithm, third edition by Ronald L. Charles and Thomas. Okay, these are the books are there, you will get in our college library. So this is what we have completed today. So what is our summary, what we have completed today? Why do we need to learn this subject? We saw this, and we saw the introduction to the course outcome, and we saw the DAA syllabus, and we saw the book references. And let me tell you the one thing, it uh, this subject graded is 3, and we have a lab also. Okay, thank you very much. We'll see you in the next class with the algorithm topic. Thank you very much. Have a good day.